Hi, in this video we will learn how to define slope of the graph of a general function, and even more important, how we can compute this value for some functions at some points. Well, let me start from the point that we all know. When you hear the word slope, you probably think of lines, straight lines. And yes, slope is something that we define for straight lines. And the way we did was this. You pick any 2 points on the line and then find the rise over run. So y2 minus y1 over x2 minus x1. This, we called it a slope. And the reason that it was well defined and it was important was that, well, if someone else does this work using completely different points on this line, meaning that, well, chooses y prime and x2 prime, x1 prime, and he or she finds this ratio, they will get exactly same number. That's a constant no matter which 2 points on the line you choose. That's where the slope came in, and it was important. Well, we want to now generalize this for the graph of functions. So I have functions graph like this one. Let's say this one. And someone wants to define what is, for example, slope of this graph at, let's say, at point C, F, C. What can you do for this one? Okay, the first guess will be, well, do whatever you did for line. Choose any other point on the graph and then find the ratio, the rise over run for that one. But right away you notice that this really depends on what point you choose. Someone can start with this point and then rise over run would be a slope of this line here. But someone else can come and choose another point and compute the rise over run for this one. These are definitely different lines, different slopes. And, well, that means that it's not a good idea just to choose any other point and then start from there. And, well, then what is the idea? What can we do for this one? First thing is that this slope of the graph, we want to first relate it to slope of a line. It's called tangent line. What kind of line is that? It's a line which barely touches the graph at the point C and FC. This is such a line is called a tangent line. So if somehow I can define that tangent line, then the slope of that I will take as the slope of the graph at that point. So that's the idea. Somehow find a way to find the slope of tangent line and define that to be the slope of the graph at that point. Well, okay, here is what people were able to do to get this thing rolling. Well, they say that, okay, let's start with any point here. I will go with the black one. This is C. This is the point that we are working on that. But any other point, you can write it as C plus H, yes? In other words, for me the distance of C and C plus H is important. So here do H. Okay. Then the point on the graph with that X is going to be C plus H and f of C plus H. Very nice. Well, then find the slope of the line passing through CFC and C plus H, f of C plus H. So in other words, the slope of the line, by the way, these lines are called secant lines. Find the slope of this line. So this is x1, y1, x2, y2. Okay, so then the slope of secant line is equal to y2 minus y1 over x2 minus x1. This gives us what? Well, C cancels with that. We get H there. F of C plus H minus F of C. Very nice. So far, it's just a line which cuts the graph into, and you get 2 points of intersections and then find the slope. But this is not by itself is not important. What will be important is when you start changing H and getting closer and closer to C. Well, for example, we can go up to this point and make H smaller, like this much. Yeah. Then the slope for this new H, with this new H, will be this one. Well, let's do a little bit more. We go closer even, this one. And then you will get this line here. And this time our H is even smaller. Get smaller. Get closer to C. So you'll get another tangent line. And you will get smaller H. Get even smaller. Well, hopefully you're getting what I'm doing here. So I am making this H here, where was it? Here. Now even smaller, this one. And none of these lines are important by themselves. But when you look at their trends as H goes to 0, in other words, C plus H goes closer to C, you see that, well, if there is any tangent line, the limit should be the tangent line. So not the slopes that we find for the secant lines, not that itself. Limit of that is what makes the tangent line, and the slope of the tangent line is that. So let me just write this. Limit of m secant as h goes to 0. This we can say definitely is the slope of the tangent line at that point. And well, we will define this guy to be the slope of the graph of f at that point, CFC. So that this piece is just definition, but this part is what we are computing. And well, this means what? This means that we have to find f of c plus h minus f of c over h. This will be a function of h. Then find the limit of that as h goes to 0. That is the definition if the limit exists. So this is basically definition. Let me just write it here and let me put this in the box. If that limit exists, we define the slope of the graph at that point to be the slope of the tangent line, which is given by that limit. Yeah, the steps that you're seeing here, well, we will repeat this thing for some examples and you will see what's happening. Let me start with one example. Find the slope of the graph of function f of x equals to x squared minus x at 0.10. Well, very nice. We have a function x squared minus x, and this is a point on the graph of that function. Means what? Means that if you plug in first component into function, so f at the first component 1, it will give us 1 squared minus 1, which is 0. So that is a point on the graph of the function. So 1 and 0. Okay, very nice. Now I need to find the slope of the graph at that point. Meaning what? Meaning that I have to do f of c, the formula is here, c plus h. C in this case is 1. 1 plus, what is h? Just write it as h. Remember, h at the end is a variable that we are going to let it go to 0. Let it get smaller and get closer to 0. Okay, so this is f of 1 plus h minus f of c is 1 over h. We have to find this ratio and then find the limit of that. Well, I will start from the beginning with the limit. Okay, this is that limit of, what is f of 1 plus h? Well, plug it in here. For x, you put 1 plus h. So I will have 1 plus h squared minus 1 plus h minus, how about f of 1? F of 1 already we have it there. It is 0 over h as h goes to 0. And let's first simplify the numerator. Well, what do we have here? 1 plus h squared minus 1 plus h. This gives us 1 squared plus 2h plus h squared minus 1 minus h. This cancels with that, and 2h minus h is just h, so h plus h squared over h. This is now a limit. The variable is h, and you want to find it. Well, if at this stage you try to find the limit, you will notice, if you have done everything correctly, you will see that you're in an indeterminate form, 0 over 0. It means that, well, the limit of the denominator is 0, definitely. And limit of the numerator is also, you see, 0. Well, I lied. Not always. If the function is a good function, you will get into 0 over 0. Well, in this case, we are. So what should we do? For 0 over 0, we always find the factor, vanishing factor. Here, the vanishing factor is h minus 0, which is just h itself. So decompose the function in the numerator and in the denominator such that you see the vanishing factors. This is the vanishing factor. This is the vanishing factor. Cancel those ones and you get limit of 1 plus h as h goes to 0. We resolve the 0 over 0. This is just a polar 1 plus h goes to 0. This will be 1 plus 0, which is 1. Well, we found the limit of this guy, And that means what? We showed that the slope of the graph at 1, 0 is equal to 1. One can go a little bit further and say that, okay, now that you have a slope and you have a point, why don't you write equation for the line? So I can write, we can find an equation for the tangent line. How? Well, we know that the tangent line has the point 1 and 0 is on the tangent line because the tangent line touches the graph exactly at that point. So it's 1, 0 is on the line, on the tangent line. And the slope we just found is 1. So go ahead, y minus y1 equals to m times x minus x1. And this is y minus 0 equals to 1 times x minus 1. And that's how we get y is equal to x minus 1. That is the tangent line to the graph, and that was the slope of the tangent line or the graph at that point. Well, let us do one more example. Here, another example. Let me see what I have. Yes, oh, this is a nice example. Find the slope of the graph of function f of x equals to root x plus 3 at what point? At point 1, 2. And also write an equation for the tangent line to the graph at that point. Okay, so let us see what we have here. So the function is f of x root x plus 3, and 1, 2 is a point on the graph. Why? Because if you plug in the first component into function as an input in the function, you will get root of 1 plus 3. It is root of 4, and that is 2. You will get the second component. That shows that this function is 1f1, and that means this point is 1f1. That means that it's a point on the graph of the function. That's nice. That's the point. Now we need to find the slope. How did we find the slope? F of c here is 1. So 1 plus, always write 1 plus h minus f of 1 over h. Limit of h goes to 0. Well, let us plug in everything there. So you plug in 1 plus h for x here. Yes. So it's 1 plus h plus 4 minus f of 2 we already computed is 2 over h. And that gives us, well, let me write it here. Why I have 4 there? This is 3 plus 3. Yes, the function is x plus 3. So now that I add, it is h plus 4 minus 2 over h, as h goes to 0. It's a fraction, it's a ratio quotient. We want to find the the limit. The first thing is the limit of the denominator is 0. You compute the limit of the numerator, you get 0 also, 0 over 0. So we have to find the limit of 0 over 0. In these cases, as you remember, we use the conjugate of this guy to be able to derive the vanishing factor from the numerator now. So what is conjugate? This it was minus. I'm multiplying the same terms but with plus. And we are dividing by the same thing so that we don't change the whole expression. Okay? Now, something multiplied to its conjugate, it will be first one squared, so it will be h plus 4 squared minus second one squared over h times root h plus 4 plus 2. Well, then this gives us, well, root square of square root is just the whatever you have under the square root. That will give me h plus 4 minus 2 squared is 4. So we have that thing there. And while these two cancels as h goes to 0, and we get limit of h over h root of h plus 4 plus 2. Now the vanishing factor we have in the numerator as factor, in the denominator we can cancel them, and we get just a nice h plus 4 plus 2 as h goes to 0. And well, now look, limit of the denominator as h goes to 0 is, well, use the limit laws here. It will be just 0 plus 4 plus 2. This is root 4 plus 2, and this is 2 plus 2, which is 4. Well, this is non-zero. That means that we can do the quotient law, and as h goes to 0, and that is how we find 1 over 4, similar to the computation I did there. What we found doing all these work, that the slope of the tangent line or the graph of the function at the point 1, 0, not 1, 0, 1, 2 is 1 over 4. So slope of the graph at 1, 2 is 1 over 4. Okay, that's what we were looking for. Although we were also interested in the equation of the function, the tangent line. So y minus y1 equals to 1 over 4 x minus x1. This gives me y minus 2 equals to 1/4 of x minus 1. Simplify. This is 1/4 of x minus 1/4 plus 2. That gives me y equals to 1/4 of x plus 7 over 8. And that is the tangent line, an equation for the tangent line for to the graph of the function at that point. Okay, so we had the idea of how to define a slope for general graph, and in the meanwhile we were able to define somehow the tangent line as limit of secant lines, and the slope of the tangent line as the limit of secant lines, and well, that way was how we define the slope of the graph.